So I'm showing you here an example, nonlinear differential equation which is to be solved by using the Bernoulli technique. And you see that this is a nonlinear differential equation. By looking at that, you don't know immediately whether it can be solved by Bernoulli technique or not. But in order to solve this differential equation by Bernoulli technique, you will have to write down it into the standard form. So to write this into the standard form, you divide everything by the coefficient of dy dx, which is y square in this case. Now we see that the equation is in the Bernoulli form. You have px for 2x, you have 6x for qx on the right hand side, and n equals minus 2. This nonlinear equation could have been solved perhaps by using the other methods such as exact, or by using the integrating factor, which we are not doing in this case. So once you realize this is Bernoulli equation, then you have to think of what is the right substitution. Okay, so in Bernoulli approach, the substitution is y to the power 1 minus n. 1 minus n, and n is here. Look at the right hand side, y to the power minus 2, which is n, y to the power 3, 1 minus 2 is 3, and you can rewrite that in terms of y. So y is u to the power 1/3. So the next job is straightforward. You take this equation, or substitution rather, and consider this equation and replace y everywhere in this equation with u to the power 1/3. So y to the power minus 2 would be u to the power minus 2 by 3. Y would be replaced with u to the power 1/3. dy dx will also be replaced with a corresponding expression which needs to be found. So apply chain rule to get this quantity for dy dx. So once you substitute u to the 1/3 for y in this equation, the end result is this quantity, and you see u to the minus 2/3 on the right hand side, and on the left hand side you have u to the minus 2/3. So you can divide everything by u to the minus 2/3, but also we don't want the coefficient 1/3 in front of du dx, so we divide the whole equation by this coefficient 1/3 u to the minus 2 by 3. So divide this term by 1/3 u to the minus 2 by 3. Divide this term by 1/3 u to the minus 2 by 3. So you get 18x on the right hand side, no u. On the left hand side, you can clearly see that it is a linear operator. First derivative and u times 6x. So you look for the integrating factor. Obviously, you could use the formula, but just don't try to memorize the formula. Instead, learn what is the integrating factor. So to find the integrating factor, you look for a first order differential equation for integrating factor, meaning that you look for an equation d mu dx equals something, and that something is coming from the second term of the left hand side, which is 6x u. But now instead of u, you just replace 6u with mu, 6x mu. The common mistake here, most people take this term to the right hand side, get a negative 6xu, which is not true. In the original equation, you have the second term on the left hand side, but when you form integrating factor, the idea is you just write the second term on the left hand side on the right hand side of your equation for integrating factor. Don't change the sign. Then this becomes a separable equation. Obviously, this first order differential equation is easy to solve, but if you don't know what is the solution, or you don't try to memorize, so just work it out. So you separate the variable, d mu by mu equals 6x dx, and then integrate. That's your integrating factor for this linear differential equation. Hence, you multiply the linear differential equation with this integrating factor. After multiplying, you just check here whether it is d dx of excuse me, if it is d dx of this coefficient, which is e to the 3x square, and you see that derivative of 3x square is 6x, so it is e to the derivative of e to the 3x square. So you can write down left hand side into a perfect derivative of the product of two quantity using product rule. Now the left hand side is a derivative, so we know its antiderivative, e to the 3x square u. So on the right hand side would be just integral of what you have. To solve this integral, again you use a substitution. Say z equals 3x square dz 6x dx. 6 times 3 is 18. So 3 integral of 6x dx would be dz e to the z dz. 3 e to the z, replace z with 3x squared plus constant of integration c. Now divide both sides by e to the 3x squared to get u on the left hand side. So what's next? You have to go back to your original variable, return back to y instead of u. So you have used u cube. Minus 3x squared, and that's your implicit solution if you wish, and it is possible to write down in this case. Okay, so let's go back and review this question, and if you don't understand anything, please feel free to contact me. Thank you.